Today let's quickly go through this problem. So in this problem you are given a series that integer array nums and a positive integer k, and you can do the following operation on the array any number of times. So you can choose two distinct indexes I and j and simultaneously update values of nums I to nums I and nums j and nums j to nums I or nums j. Here or means bitwise or operation and n means the bitwise and operation. And we have to choose k elements from the final array and calculate the sum of their squares, and the sum of square very large, and we have to modular 10 power of 9 plus 7. So take a look at the first example. So the input numbers is 2, 6, 5, 8 and k equal 2, and the answer 261. Why? Because we can do the following operation on the array. So we choose 0 and 3, and then we mark 0 as 2 and 8, and it becomes 0, and nums 3 becomes 2 or 8. In bitwise it becomes 10, and the resulting array after this operation is 0, 6, 5, 10. And then the second operation we can choose 2 and 3, and then again after doing this operation the resulting array is 0, 6, 0, 15, and then we can just choose 15 and 6 from the final array. Because k is equals to 2, we just pick a 2. Two of them is 15 square plus 6 square, which is 261. So that's why we have this answer. So the constraint is nums length can be 10 to the power 5, and then k can also be 10 to the power 5, and then the value can be as large as 10 to the power 9 as well. So it means that basically have to do an ON solution. So that's basically all for the problem description example. Let's see how can we actually solve the problem. Let's take a look at first hint. Since the problem is doing OR and AND operator, it makes sense for us to just convert the numbers into a binary form first. For instance, the example input is 2, 6, 5, 8. We can convert them into binary numbers like this, and the sample explanation says the result will be the sum of 15 squared plus 6 squared eventually. So 15 in binary form is 111, and 6 the binary form is 0110. That's probably a little bit abstract. Let's try to draw a diagram to visualize that. So the example input is this, and then we convert them into binary form for each number. And the first thing you notice is that in the final array, the number of turn-on bits are actually the same as the number of turn-on bits in the original array. So what I'm trying to say is that there is 1, 2, 3, 4, 5, 6 underlying, and there are also 6 underlying in the final array. So, and also every turn-on bit in the final array must also appear somewhere in the nums. It makes sense, right? Because we're doing AND and OR operator. You cannot just suddenly appear some bit in this position while all of the previous number are turned on this. And because we have to assign AND to a pair and also assign the other number to OR, so it means that if you look carefully, let's assume we do an AND operator on 5 and 8, and it will become 0. But for the OR operator, it will become 1, 1, 0, 1. So like the turn on bits just don't disappear, they just move position. In other words, we can just really move the turn on bit to every position that we want. So as here, so if we just run some more example, then we can realize that we can just move all the bits everywhere we want using this operation, those bits. So assume ith bit has 5 occurrences. We of course want to put it 5 times if k is larger or equal to 5. That's how we're going to construct our solution. So for the pseudocode, we just calculate how many times do each bit appear and then use them for at most k times. So that's pretty much all for the solution overview. Let's see how can we actually implement that in code. So first I'm going to just write some assert code just to ensure it's working for the sample test case, and if everything is working, then it will print all tests as passed. So go on with the implementation of code. First, we're going to initialize the mod, which is 10 to the power of 9 plus 7. And then, as mentioned, we'll be recording the occurrences of each bit. So this is how we're going to record them. You just iterate every numbers in given input array, and then just go through all bit. And if that bit is turned on this particular number, then we just plus equals 1 for this count. And then we can start calculating our answer. We first initialize that into 0, and then we're gonna fill k numbers, right? So for this first number, then we're gonna initialize that into 0, and then we're gonna look for every bit. And if this bit is turned on, then we're gonna use this bit on the current. So that's why we can just plus equal to this turn on bit, but we have to left shift that I times code stands for the ith position of the bit. And then after doing that, we have to subtract the occurrence of this bit by 1. And then for this current number, we just need to do a square before adding that to the answer. And then we also have consider the mock. And then on line 17, we're just gonna return the answer. That's pretty much all for it. And for the time complexity, it's gonna be on, simply coming from this for loop. And also, I forgot to mention this should be in plus k, because for the other for loop, you're gonna loop k times, and then for the state complexity is going to be 01, because the only thing that we store is this array, which is just 32, so it's a constant, so we can just assume that it's 01. So that's pretty much all, and let's try to run this code and see if it's passed that sample test case. Okay, it passed. You can copy this code to LeetCode.com and submit the forum, and this will pass as well. And I will post the link of this text solution in the description box below so you can check out. And that's pretty much all for it. Thanks so much for watching, and I will see you next time. Bye bye.